The AM can be adjusted to the sample by tilting and rotation. Use the key for the null screw to unfasten it. Now you can adjust the height of the AM and rotate it so the microsensor points in the preferred direction. When in position, fasten the null screw again tightly. Then adjust the tilting angle and fasten the locking screws of the tilting platform. Please always keep a firm grip on the AM with one hand while it is not fixed in position. Use the manual motor drive to place the sensor tip near the sample surface. Whenever you remove the AM from a fixed position, make sure the microsensor tip is retracted. Move the sensor away from the sample using the coarse drive. Again, hold on to the AM with one hand while unfastening the screws. This is how the AM setup can be adjusted. For the following profiling, we are going to use the AM for vertical movement into a sediment sample. Once your meter is connected, you will have to start with calibrating your microsensor. Click on New and select the sensor type of the connected microsensor from the drop-down list. Then click Create a new calibration. Enter a calibration name and optionally a comment. Then go to the Constants tab. You can find the sensor constants on the final inspection protocol delivered with your sensor. Enter the values in the respective input fields in the software. Then go to the Calibration tab. In case you are performing a 2-point calibration, check if the O2 second matches the O2 content of your calibration solution. Enter the current atmospheric pressure value and select the calibration mode and user signal intensity. Go to the time series window, select an interval for the following calibration measurements and enter the calibration temperature, or get it from the device if a temperature sensor is connected. Start the time series measurement and insert the microsensor and temperature sensor in the calibration solution called second. Wait for about 3 minutes for the phase and temperature value to adjust. When the variation of phase and temperature value is below 0.1, press the Get Value button next to the Cal Second input field. The measured values will be stored. Now insert the microsensor and temperature sensor in the calibration solution Cal 0, and again wait for about 3 minutes for phase and temperature values to adjust. When the variation of the phase and temperature value is below 0.1, press the Get Value button next to the Cal 0 input field and the measured values will be stored. Stop the time series measurement, save the calibration data and load it. Prior to creating or loading a profiling template, you will have to do the zero level adjustment. Click the button in the control bar and wait while the AM moves to home position. When the referencing is finished, the AM will rest in the top position. Now you can extend the microsensor tip. Click the Activate Manual Movement button so you can use the linear stage manual control to move the microsensor tip towards the sample surface. Additionally, you can make adjustments with the AM's coarse and fine drive. For fine adjustments, you can also enter a movement distance and movement speed, and then click the Move Up or Move Down buttons to shift the microsensor tip in single steps to the exact zero level. When the microsensor tip is in position, you can set the new zero level and create or load a template. On the Profile tab, you can enter a comment for this measurement and enable multi-profiling, so several measurement runs are performed in series. Enter the measurement temperature or click Get from Device if you have a temperature sensor connected. Adjust the measurement mode and if necessary, input the salinity of your sample. Now you are ready to start the profiling measurements. The measurement values will be displayed in the graph. When the profiling measurements are finished, the AM will move to standby position. Then you can save your results. All data collected in one experiment, here 3 profile runs are stored, can be exported to one file. Go to the File menu and click Export. Select the experiment, choose the oxygen unit and file type you want the data exported in, and store the file to a directory on your PC. When you open the file in Excel, the data is shown on different sheets. Experiment gives general information about the software and the meter. On the profile sheet you can see details about the different profiling runs stored in this experiment, and time series recordings gives all data recorded in the time series window. The oxygen calibration sheet shows all applied calibration data, and templates gives information about the used profiling templates with details about all defined zones. On oxygen profile details, all single measurements are listed, while oxygen profile averages shows the averaged measurement values and annotations you entered.